Afternoon, trigonometry. Here's a video taking you through a bunch of Regents question on arithmetic sequences and series. One of the first thing I want to show you is what you're going to have in terms of different formulas. These two up top, you're only going to have them on June 17th for the regular one, and these bottom three, which is actually even nicer, you'll have on June 1st, which is for Common Core. All right, you'll have the general term for an arithmetic sequence, a geometric sequence, which is really nice, and they'll give you geometric series. The one they're not giving you is arithmetic series, and that's actually the easier one to do. So I think you'll be happy with that. Let's take a look at what some Regents questions might look like. What is the common ratio of the sequence 1/2, 3/4, negative 9/8? Well, really important word in this statement is ratio, common ratio. Whenever you see common ratio, that means we're talking geometric, and that means we're going to be multiplying. And here's the thing, if you're not sure, because it's not that easy to see, how you're multiplying, what are you multiplying 1/2 by? I start at negative 1/2, I multiply by something, and it's going to give me 3/4. Here's really simply how you could solve that. You just take your something and isolate it. So divide by negative 1/2. You divide by negative 1/2. And if I'm doing this in my calculator, I'm probably going to go in parentheses 3/4 divided by, in parentheses, negative 1/2. And I'll get negative 1.5, or as a fraction, negative 3/2. So remember, if you ever have to find the common ratio, it's going to be equal to the future term over the previous term. All right? And I know we're multiplying, but that's why the word ratio gets used, because that's how you find it. Future over previous gets you your common ratio. For an arithmetic sequence, the first term is 10, and the sixth term is 40. So let me do this how I think you guys might do it. Term number 1 is 10. I don't know the second, third, fourth, fifth, or even the sixth, or I do know the sixth term. It's 40. Now I just have to figure out how big of jumps am I making from here to here, 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 up to here. That's the question. And if you look, starting from 10, I have to add something once, twice, 3 times, 4 times, 5 times. So if I start at 10 and I add something 5 times, I should get 40. That's just a little bit of side work to get ourselves going, but when I figure this out, it's really, really helpful, because I have now 5x equals 30. Divide that 5 over, and you'll find x equals 5. Nope, you'll find x equals 6. X equals 6 is our common difference. That's actually our common difference, because if I go 10 plus 6, I get 16, plus another 6 is 22, plus another 6 is 28, plus another 6 is 34, and plus that last 6 puts me perfectly on 40. So, knowing that common difference of 6, what I would want you to grab is that arithmetic sequence formula they gave us on the reference sheet. Arithmetic sequence, right here. Reading that, a sub n equals a sub 1, that's the first term, plus n minus 1 times the common difference. So back to our problem. A sub n would equal a sub 1 plus n minus 1 times the common difference. I know the first term, it was 10, plus I'm trying to find the 20th term. So this is for a sub 20. So 20 minus 1 times a common difference of 6. 10 plus, that'll be 19 times 6, which is 114. That's not, is that right? 19 times 6? 114, yep. So 10 and 114 would be 124. And that's how you might want to do this problem. again, use your reference sheet, use your resources to help you. Given the sequence x, x plus y, x plus 2y, which expression can be used to determine the common difference? We showed common ratio before. Here's common difference. Common ratio, just as a reminder, was the future divided by the previous. So common difference, what operation do we think when we hear difference? That'll be the future minus the previous. So here's the thing, when I'm looking at this sequence, if I start at x, what's the previous term from x? Oh, that's right, I have no idea. So I'm not going to do that one. Okay, which kind of, this one starts with x, so I'm going to rule that choice out. If I start at x plus 1, though, x plus y, I'd want to be subtracting x. I don't see that here. And if I move finally to the third term, x plus 2y, I would want to subtract x plus y. That's our choice right here. Really, choices 3 and 4, they were a common ratio. So as soon as you recognize those don't have a difference in them, scratch them out. All right, fourth term of the sequence defined by this. Just seeing your ability to plug in. I believe we had this in our green book the other day, so I'll do it very, very quickly. The fourth term. Well, if you start with the first term, 3x times y to the fifth, the recursive, this is a recursive formula here, is telling us to just multiply the previous term by 2x over y. So times 2x over y, that'll give me the term 6x squared y4. That's my second term. Repeat the process. I'm going to get 12x cubed y cubed, and that's my third term. I want my fourth, so repeat it one more time, and I get 24x4 y2. It's choice number 3 right there. And it's a question about being able to read a formula, knowing that this just means a sub n minus 1 just means the previous term, and how to work with a recursive sequence. Okay, first 4 terms of the sequence are defined by a sub 1. Oh, just find them. This is easy. And, okay, this is not that easy. But if you start with a sub n plus 1, and you subtract a sub n. This is another way of saying it, but basically, this will be our present term. And then plus 1 would send us 1 into the future. So it's just another rewording, but we can still do this. So we're going to start from our first term. We know it's 1/2. How do I get to my next term? Well, to get to my next term, I'm going to do 1 minus the present term. And that will give me 1/2. Now, when I want to get the next term, I'm going to do 1 minus my present term, which is 1/2. And that's just going to give me 1/2. And then when I want to get my next term, my fourth term, I'm going to start with 1, and I'm going to subtract my present term, which is 1/2. And it is really that weird, that repetitive. It's a recursively defined sequence that's kind of stuck in a closed loop of always producing 1/2. All right, so the last couple questions I have to look at. Let's see how many more there are. Maybe 5 or 6 more. I think most of them deal with sigma notation and reading and interpreting sigma notation, which just means sum it up. When you see a sigma, this is my note from topics today, this means to sum. Usually we're going to have like n equals down here or something. You're going to start at this number. You're going to have something up top here. Maybe we'll give it a 7 for there. And that's when you're going to stop. That's going to be the last number you plug in. And you're plugging into whatever function is over here. Whatever function. So if this said n equals 3, we would start at 3. We'd plug 3 into the function. After 3, we'd go to 4. We'd plug 4 into the function. We'd plug in 5. We'd plug in 6. We'd plug in 7. And would we plug in 8? No, we'd stop because we're going to stop at 7. So let's use all that information to help us answer this Regents question. Here is our sigma. We're going to start at 0. And 0, you can see, is going in for x. So we've got 3 minus 2a to the 0. Okay, that was easy. Plus, sigma means sum, 3 minus 2a to the first, plus 3 minus 2a to the second. And I stopped at 2 because the top number was 2. Now, we do have to evaluate this. It's a little bit more work than that. Anything to the 0th power, it's easy enough. That's just 1 plus a binomial to the first power is just itself, so it'll be 3 minus 2a. And then this is really where they expect you to have problems, because so many people are going to say 9 minus 4a. But that's wrong. You have to write 3 minus 2a times 3 minus 2a and FOIL that. And when you FOIL it, you'll get 9 minus 6a plus 4a squared. And now it's a matter of just cleaning this up, looking for like terms. So 1 plus 3 plus 9, I think those all add up to 13. I know my a squared is by itself, so we'll put a 4a squared out front. And negative 2a with negative 6a would make negative 8a. Did I do it all right? Of course not. How would that happen? Where is my mistake? Well, I'm going to guess it's choice 4. No, I can't guess that. I'm going to guess it's 2 or 4 because I have my 13 and my 13. Chances are I probably messed up when I was foiling. Oh, that's where it is. 3 times negative 2 is negative 6a. Negative 2 times 3 is negative 6a. And this should have been a negative 12. So negative 12, negative 2, this will be a negative 14. And choice 4, my initial guess was correct. All right, but that's sigma notation. Another recursive here. The third term in the sequence. Okay, you want to find it. Here's the second term. Half of the previous term, half of negative 6, minus the n. Well, n here is just 2. So half of negative 6 is negative 3, minus 2 is going to give me negative 5. That's my second term. Now to find my third, I do half of the previous term, and I subtract the number of the term, which is 3. Well, half of negative 5 is negative 2.5, and minus 3, that'll get me to negative 5.5, which would be, as a fraction, negative 11 over 2. More recursively defined stuff. Next 3 terms of the sequence. Expressed as fractions reduced in lowest terms. This is pretty easy, I think. You're just using the previous term. So our first term is 2. After that, we're going to do 3 times the previous term to the negative 2. After that, well, we're going to need this term. Hold on. So 2 to the negative 2 will be 1/4. So this whole second term is 3/4. All right, so that's our sequence so far. 2, comma, 3/4. Setting it up again. 3 times the previous term to the negative 2. You can do that in your calculator. Here it is. As if, let's put it in parentheses. Parentheses, grab that fraction, 3 over 4, wrap it up, put it to the negative 2. I don't know why I didn't do this the entire time, but I times 3 for that, because there's a 3 out front. 16 over 3 is what my third term is. 16 over 3. And now my last setup is just going to be 3 times 16 over 3 to the negative 2. And I'll go to my calculator for that, which is 3 times, use those parentheses, 16 over 3, close it up to the negative 2. And I got 27 over 256. 27 over 256. I believe that's in simplest terms, but if not, we'll just check it, math frac it down. Yeah, that's as low as it can go. So that's it. Those are your 3 terms. And that's this is a question 37. So this is probably a 4-point problem. 4-point problem right there. Moving on, more sigma for us to do. And they're throwing in a trig function now too. So here we go. Let's start at 1 and plug in cosine of 1 times pi over 2. That's my first term. Plus, start it again. After 1, we're going to use 2. Cosine of 2 pi over 2 plus cosine of 3 pi over 2. I don't want to make any mistakes, So I'm going to leave everything just like that, and I'm going to do it in my calculator. The only thing I want to make sure of, because I see a pi in the problem, pi, generally speaking, means radian mode. So if I'm in radian mode, I should be all good. I'm not. Switch it into radian mode, and let's set this baby up. Cosine of 1 pi over 2, close that up, plus, you actually could have done this whole thing in your calculator. I'll show you that in a second. Cosine of, get a fraction, 2 pi over 2, close that up, plus the cosine of, grab that last fraction we're going to need, 3 pi over 2, close it up, and final answer, -1, which is choice 2. I said that you could do this entire problem in your calculator. Here it is, a little calculator trip. Math, scroll down to the bottom for summation, and you can plug all of this in. Even if you want to use the letter n, you can press alpha n, so n equals 1 up to 3 of, the new function is cosine of, grab that fraction, alpha n pi over 2, and if Mr. Steiner did all this right, yep, didn't like that parenthesis, so we'll just get that out of there. Same answer, -1, totally in the calculator. All right, simplifying this, another summation. I'm just going to expand it out. I'm not going to do all the work, but start at 1. I'm plugging in for the variable a, so that's x minus 1 squared plus x minus 2 squared plus x minus 3 squared plus x minus 4 squared. And I'm stopping at 4. If I do simplify this, this will be x minus 1 plus x minus 4 plus x minus 9 plus x minus 16. And combining like terms, x plus x plus x plus x is 4x. How about adding these up? Minus 30? Minus 30. 4x minus 30. Final answer, done and done. And this is my last question. This is my last question. Which expression is equivalent to the sum of the sequence 6, 12, 20, 30? If they give you the formulas as answers, you might just want to try to plug in. And if you plug in 1, or whatever first number you plug in, you should get 6 out. And if you don't, then it's not the right one. Something else that might help is to look to see, is it a common ratio or a common difference? Well, 6 to 12 goes plus 6. But if I try that again, plus 6, it does not work. It's not a common difference. It's a common ratio. So maybe not that helpful, but I can recognize that this is arithmetic, so it's not going to be that choice. If we take a look, yeah, I mean, probably just easier to mess around in the calculator. 30 and 20 is 50, and 62, 68. So which one of these in your calculator will give you 68? My guess will be 4 squared, or 4 plus 6. That one right there, choice number 4. So that's it. Those are Regents questions. That's from all of the last 3 Regents exams on sequences and series. Thanks so much for watching.